Everyone. Today we're going to do part two of arithmetic sequences. We're going to learn how to write equations when we're not given perfect data or perfect information. And we're also going to see a good use for arithmetic sequences. So once again, arithmetic sequence, there's a common difference. So we go up by the same amount each time, either through addition or subtraction. We can go up or we could go down. So a problem might give us that term 2 is 14 and term 6 is 4. And they want us to write equations. So ideally, I'd like term 1. I don't have that. Ideally, I'd like to know the common difference. Don't have that either. So that's problem 1. Okay, how do I find term 1? How do I find the common difference? So since arithmetic is like linear, we're going to do something similar to finding slopes. So we don't know term 1, we know term 2 is 14, and 3, 4, 5 we don't know, and then term 6 we know is 4. And this might be helpful to write out as you're learning it to figure out how many steps do I need to take. So the common difference, if it's arithmetic, we're going to do it like we do slope. So change in y, so change in number over how many terms. So what's the difference of the terms versus how many terms did we go through? So we do 4 minus 14. So we changed by negative 10 over from step 2 to step 6. So each time we're going down negative 2.5. And if you're not sure, subtract 2.5 each time and check that you get to 4. So we now know that our common difference, D, is negative 2.5. Now we can find term 1, because if we know term 1 minus 2.5 gets us 14, we can write an equation. So term 1 minus 2.5 is term 2. So term 1 minus 2.5 is 14. Okay, we're going to solve for T1. So we're going to add 2.5 to both sides. And now we know that this term, term 1, is 16.5. So now we know term 1, and now we know the common difference. So we can write a formula. So we know T1 equals 16.5. We know that the common difference is negative 2.5. So in first term form, okay, T of n equals our first term. Now we have a minus because we're going down, so minus 2.5 is our change, times n minus 1. And you could check, you could put 2 in here and see that you get 14 out. Or you put 6 in to get 4. I recommend always checking at least one of them. Okay, now the recursive, to get from a step to the next step, we subtract 2.5, and then I got to give you some sort of information, some sort of initial condition. So term 2 is 14. I could tell you term 6 is 4. I could tell you term 1 is 16.5. As long as I give you at least one of the terms, and then the recursive formula, that's all I need to do. And I can pick any term I want. Now, what happens if they want us to figure out where 1128 is in this sequence? So, first thing I could do, I could write out every term. So I could write out 8, 12, 16. I see it's adding 4 and keep adding 4, keep adding 4, keep adding 4 until I get to 1128 and count how many numbers I wrote down. That's crazy, inefficient. No one does that. I could, however, write an equation and then find out what n is. And that's what I'm going to do. So this one, I know my first term. I know my common difference is 4. So I can write an equation using those two pieces of information. Wrote in first term form again. So 8 is my first term, 4 is my common difference, times n minus 1. I then want to solve what's 1128? What is n? What n value gets me 1128? And then it's arithmetic. So I'm going to subtract 8. I'm going to divide by 4 on both sides, and then I'm going to add 1. And you need to practice writing these down. And you wind up getting n equals 281. So 1128 is the 281st term in the sequence. Now, if you get a decimal, it's not going to be in the sequence because n has to be an integer. And in this case, I got n as 281, and my work here is done. So I can use the sequences to write out the terms. I can use my sequences to write an equation, and then I can find out what term number anything is. And that's arithmetic sequences.